Well, howdy, welcome back to Multar Aviation. So in this video, I'm going to be wrapping up the Part 7 weather aviation series, talking about the jet streams. So I'm Dr. Andy Molter. I'm a flight instructor of CFI IIMEI. I'm a former corporate pilot, and now I'm a professor of aviation. And aviation weather is one of those classes that I teach, so you're getting free college education. So make sure you subscribe. That way you can continue to get notified every time I make one of these videos. All right, so the jet stream, I know you've heard about it. It's at higher altitudes, jets will be flying, and if they can fly in the jet stream with the direction of the wind, then they're going to be able to go a lot faster without having to use any extra fuel. So that's why the airlines like to take advantage of flying the jet stream. Now, if you're going the opposite direction, well, then you're fighting against the wind, and so you're going to fly longer. Therefore, you're going to use more fuel. But what is a jet stream? So the jet stream is just really a relatively narrow band of strong wind in the upper levels of the atmosphere. The wind blows from west to east in the jet streams and often flow from southerly to northerly. So there's a lot of factors that go into it. And remember, if you've been watching my aviation weather videos, I'm always saying everything that we're learning in these videos is just a piece of the puzzle. And by learning everything that we can about the weather, then we can actually kind of understand what's happening. So jet streams follow boundaries between hot and cold air, and jet streams are strongest in the winter in both northern and southern hemispheres. And so I'll talk more about that here in a little while. And then, as noted earlier in my previous video, there are three circulation cells in the northern and southern hemisphere. And I don't know if you can name them. Remember, they're the Hadley cell, the Ferrel cell, and the polar cell. Well, the motion of the air is not directly north or south, as we talked about in that last video. And so I'm not lying to you. It's just that, everything we're learning, it's kind of like a way to think about the weather. And so you have to combine all these different factors to then come up with how the weather works. And so the strongest jet streams occur where the temperature changes are the greatest, which occur around 30 degrees north or 30 degrees south, and then also 50 degrees north, 50 to 60 degrees north, or 50 to 60 degrees south. Kind of like where the Hadley cell meets the Ferrel cell, where the Ferrel cell meets the polar cell. And so, and the altitude at which these jet streams occur vary in height from 4 to 8 miles, and they can reach speeds more than 239 knots. And so this picture here on the left, this is just, some random, I mean, it's not random, but it's just one way to depict how the jet streams flow. When you look at a prognostic chart, which we'll be looking at that kind of stuff, in later video series on aviation weather, but you know, the jet streams don't go exactly like this in a circle around the Earth like so. It gets a little bit more complex, and it depends on a lot of factors. And so here's just a visualization of where the jet streams occur. And so if you imagine here on the left, this is where the North Pole is, and then you have your polar cell, and then in between, and then so here, yeah, the polar cell on the left. Then we have the Ferrel cell from 30 to 60 degrees north, and right here at the edge between the Ferrel cell and the polar cell is where we'll have our polar jet stream. And then the subtropical jet is in between the Hadley cell and the Ferrel cell at around 30 degrees north. And then you notice the top here, this red line, this is the tropopause. So this is where we can use the jet stream, the location of the jet stream, to kind of determine where the tropopause is. So in this picture here on the right, we see the visualization of a jet stream. And so the actual appearance of the jet streams result from the complex interaction between many variables such as location of high and low pressure systems, warm and cold air, and seasonal changes. So there's lots of factors that go into where the jet stream is located. A jet stream may be drawn on a chart, but they're much wider in reality. And so, and you kind of want to think of it as a river. And so if we're looking at this picture on the right, what's going to be depicted on a chart is the center of this jet stream. And so the center of the jet stream is where it's going to be the fastest. But as we go away from the center of the jet stream, the speed of the air gets less and less. So if you're on this outer area of the jet stream, yeah, I mean, the wind is 80 miles per hour. But as you get more and more into the jet stream, then it's like 140 miles per hour. So that's a pretty big difference. Now, the jet streams move north in the spring to summer and south during the autumn to winter. All right, so let's look at this picture here and try to understand why the jet stream is weaker in the summer and stronger in the winter, and why it moves from south to north or north to south. So let's say we're in the summer. In the summer, the temperature is going to be hotter, and so as air gets warmer, the pressure decreases. Now, here in Florida, it might be like 90 degrees, maybe 100 degrees. But then if you lived anywhere on the East Coast, in the summertime, 90 degrees in Florida could be 90 degrees, South Carolina, North Carolina. And then as we keep going up in latitude, it could still be 90 degrees in New York. And so there's not much temperature change. And so since there's not much temperature change, there's not going to be much pressure change. But then then the fall comes along, the winter comes along, it starts getting colder in the north, but it still stays relatively warm in the south. So here in Maine, New York, Vermont, New Hampshire, all that area, it can get quite cold. We're talking about teens, negative temperatures when we're talking about Fahrenheit. But then as we go down south to Florida, well, it could still be 60s, 70s, so relatively nice weather. And so that's a big temperature change, and therefore you have a big pressure change. And so if you go back, and if you haven't watched it yet, please go back and watch those pressure videos. But remember, when you have an area low pressure, that's kind of like a sucking force. An area high pressure is a pushing force. And so and when you have a big change in temperature, you have a big change in pressure. That means the winds are going to get stronger. So, when it's nice and warm, relatively warm in Florida, and then really cold in the winter, then yeah, it's going to be a big temperature change, and therefore the jet streams are going to get stronger. Well, that's it for part 7. So, if you haven't watched the first video, part 7A, and then you've seen this part 7B video, how will you remember the information? Where's the Hadley cell and how does the air flow? Where's the Ferrel cell? How does that air flow? Where's the polar cell? How does that air flow? Where do the jet streams occur? What makes the jet stream stronger? So, all right. Well, I'll see you in the next video. If you have any questions, leave them in the comment section. I'm happy to answer. And please like the video, and if you want to see more of these videos, please subscribe. That way you can get notified every time I come out with a new video. All right, thanks for watching. Bye.